In the previous video, we talked about how to read a chemical equation. And one of the things we mentioned was something called a coefficient, and that it was used to make sure that the types of atoms on the left side, reactant side, matched the ones on the right side of the product side. And so we're going to learn how to read or calculate whether something is balanced. In this class, we're not actually going to balance the equation, so you may have done that in a previous chemistry class, but in this class, we're just going to see, is it balanced? You will not be balancing the equation, so you don't have to figure out what numbers go in the front. You'll only look at some equations and say, yeah, this is balanced, or no, it's not balanced. So let's look at this equation that we've looked at before. Now we're going to check to see if it's balanced. So the easiest way to do this is to list down all of the elements that are present on the reactant side, and then those should be the same elements that you'll see on the product side. Then on the reactant side, just total up how many of them there are, and then on the product side, see that it matches. If everything is exactly the same, it's balanced. If they are not the same, it's unbalanced. Again, you will not need to balance them in this class. So let's start by making a list of all of the elements that are present. Looks like we have zinc, hydrogen, phosphorus, and oxygen. Notice that I did not include this X and Y that we have on top because those are part of the catalyst. They are not a part of the equation. They're not going to be reacting. They're just there to help along. Now I like to make a little crossbar here, and then I put reactants on the left, products on the right. And for the reactants on the left-hand side, what we see is there are 3 zincs. Remember that coefficient multiplies. And then there are 6 H's because we have 2 times 3 H's. And there are 2 phosphorus and 8 oxygens. That's on the reactant side. And for our products, we see there are 3 zinc, 2 phosphorus, again because we have the parentheses, everything inside the parentheses is multiplied by it, 8 oxygens, and 6 hydrogens. So because everything matches here, we know that this is a balanced equation. Let's try a few more. Let's look at this reaction between FeCl3 and CaBr2, and it forms CaCl2 and FeBr3. So the elements that we see are iron, chlorine, calcium, and bromine. Let's go ahead and write in our reactant and product header. I'm going to go ahead and put 1 for the iron, 3 for the chlorine, 1 for the calcium, 2 for the bromine on the reactant side. And on the product side, I see 1 for iron, 2 for chlorine, 1 for calcium, and 3 for bromine. Notice that the chlorine and the bromine do not match correctly. And this tells us, as soon as we see any one of them not matched, we know that this is not a balanced equation. So this is not currently correctly balanced. I'm going to have you try this second one. Go ahead and pause your video, and when you come back, we'll go through the answer. I hope it went okay for you. So let's go ahead and list down the elements. In this case, we only have 2 elements, hydrogen and oxygen. Put our header up here. We have reactants. On the reactant side, we have 2 times 2 hydrogens, which is 4 hydrogens, and 2 times 1 oxygen, which is 2 oxygens. On the product side, we have 2 times 2 hydrogens, which is 4, and 1 O2, which is 2 O's. It appears the H's and the O's all match, and so this should be a balanced equation. Now let's try some harder ones. For this set, I'm going to show you 2 different methods that can be used to figure out if it's balanced or not. First, I'll show you the method we've been using. So we'll start here with iron acetate. We're going to write all the elements that are present. We have iron, Fe, carbon, C, hydrogen, H, oxygen, O. And then on the calcium sulfate, we have Ca for calcium, S for sulfur, and O for oxygen. And we already had an oxygen, so we're going to add those 2 together. We're not going to keep them separate. So obviously this one has a lot going on. So when I read out these, you're going to see that I multiply by the coefficient first. Then I'm going to do, if there's parentheses, I'll do what's on the outside of the parentheses, and then I'll do the subscript for each element. So that's just the way that I do it to make my pattern always the same. So we'll go ahead and do the reactants first. So we'll look at iron. We have 2 times 1 for a total of 2 iron. Then we have, for the carbon, we have 2 times 3 times 2, which is a total of 12 for carbon. Then for hydrogen, we have 2 times 3 times 3, which is 18 for the hydrogen. Then we have oxygen. Now I'm just doing the one for the iron in the iron acetate first. We'll come back to the other part later. So for the oxygen, I have 2 times 3 times 2, and so that is 12 oxygen so far. Then we look at calcium, and we have 3 times 1 for 3, and sulfur is 3 times 1 for 3. Now let's look at that oxygen again, and now we're going to add that in from the sulfate. We're going to have 3 times 4 for 12. We're going to add those two together, so the 12 from the iron acetate plus the 12 from the calcium sulfate, all of those oxygens added together are 24 oxygens. That's our reactant side. Now let's look at the product side. So we're going to start with, I always do it in the same order because I'm filling out this chart. So we're going to start with iron. So there's 1 coefficient times 2 in the subscript, so 2 irons. Next we look at carbon, which we have 3 times 2 outside the parenthesis times 2 subscript for a total of 12 carbon. Then we look at hydrogen, and we have 3 times 2 times 3, which is 18 hydrogen. Now oxygen, we're going to add these together, but again, we're going to start with just the one for the acetate. We have 3 times 2 times 2, which is 12. Now we'll add in the oxygens from the iron 3 sulfate, and for that, we're going to have 1 times 3 times 4 for a total of 12 oxygens. We add those two together, and we get a total of 24 oxygens on the product side. We still have the calcium left, which is going to be 3 times 1 for a total of 3, and the sulfur, which is going to be 1 times 3 for a total of 3 sulfurs. And now we can look at all of those, and we can see that everything matches up. So 2 irons, 12 carbons, 18 hydrogens, 24 oxygens, 3 calciums, and 3 sulfurs on both sides. Now we're going to look at the second method. Now this one I find to be much easier because they're not doing quite as much multiplication, but you have to be sure that when you do this that these actually match. So in this case, we have acetate ion on the reactant side, and we have the acetate ion on the product side. We also have the sulfate ion on both sides. Now those match. If I had an SO4 on one side and an SO3 on the other side, that would not match, and we couldn't use this simplification. We're going to go ahead and try the simplification. For this, what you're going to do is you're going to find either elements or groups. Now the groups are going to be the things that you already know. So like we already know the acetate ion, we already know the sulfate ion. So those are the types of things that we're going to use as a group. And they're matched on both sides of the equation, so they're not falling apart, they're not breaking apart. We're just going to look at the whole group at one time. So the first part, just list what we have. So we have iron, we have the acetate ion, we have the calcium, and we have sulfate ion. So those are our 4 things that we're going to be looking for. On the reactant side, we can see that we have 2 times 1 for iron, and we have 2 times 3 for the acetate. Then we can see that we have 3 times 1 for the calcium, and 3 times 1 for the sulfate. Notice there's no bracket around the sulfate, but that whole group is multiplied by 1. So because we recognize it as a group, we know that because it's not being multiplied by anything, there's no parentheses, but it is still a group, and we're going to count it that way. Then we're going to look at the second half, and we'll look at the products. So here we see, for iron, we see 2 times 1 for the iron, for 2. And then we look at acetate, and we see 3 times 2, which is a total of 6 acetates. Then we look at calcium, and we see 3 times 1 for 3. And we look at the sulfate, and we see 1 times 3, and that's going to be 3. So as you can see, this is still a balanced equation. Of course, that shouldn't change, but this is a quicker way of doing it, not quite as much to multiply out. So if you have a group like this, you're welcome to use them. Just be very careful that the groups are exactly the same. We'll do one last one. For this one, I like to do it slightly differently. It really is the same process, but I want to look at it really quickly to see, does it match or doesn't it? So for this, I'm just going to look at the carbon. I'm going to see there's 5 here and 5 over here, and hydrogen, there's 12 here and 6 times 2, so 12 there. So really the only thing we need to really compare here is the oxygen. So when I do this one, what I like to do is make everything into an O2 on both sides to see if we can get there. So I've got 8 O2s on this side, And I've got one extra one, don't forget about that one. So next we want to look at the other side. On the product side, we see that we have 5 O2s in the CO2, and for the water we have 6 O's, but that's the same as 3 O2s. So I can see that these are all O2-ish, which means that what I have left over is one extra one on the reactant side. So I can tell right away without doing any calculations that there's something wrong. One has an odd number of oxygens and the other one has an even number. So just as a quick estimate, we can see that this one probably is unbalanced. But we're going to go ahead and do the calculation now just to make sure that we have it correct. Alrighty, so we have carbon, hydrogen, and oxygen. Notice that oxygen is all over the place, and that's why that one is the most difficult one to calculate. So if the other ones are quick and easy, just glance at them, see if they appear to be right, then you have to look at the oxygen. If one of those was wrong in the first place, like let's say I had 12 H2Os, then obviously the answer would have been wrong and I wouldn't have to go any further. So let's go on with this. So on the reactant side, we have 5 carbons and 12 hydrogens. And then we'll look at the oxygens. And again, on our product side, we have 5 carbons and 12 hydrogens. So those ones are the easy ones. We're looking at the oxygen now. We have 1 on the reactant side, plus 8 times 2, which is 16, for a total of 17 oxygens on the reactant side. On the product side, we have 5 times 2, which is 10, and 6 times 1, which is 6, which is 16. So 17 oxygens on the reactant side and only 16 on the product side. This is not a balanced equation.